Why do temperature and flaws lead to brittle fracture? Have you ever wondered why some materials break suddenly without bending or stretching? This phenomenon is known as brittle fracture, and it can be influenced by temperature and flaws in the material. Let's take a closer look at how these factors come into play. When temperatures drop, many materials, especially metals like steel, become more brittle. This means they lose their ability to deform without breaking. There is a specific temperature known as the Nil-Ductility Transition temperature, or NDT temperature, where this change occurs. Below this temperature, materials cannot absorb much energy before they fracture. This leads to cracks forming and spreading quickly, often without any warning. Now let's talk about flaws. Flaws can be cracks, voids, or inclusions in the material. These imperfections act like stress concentrators. When stress is applied, these flaws amplify the local stresses around them. If the stress becomes too high, cracks can start to grow. At low temperatures, the material's toughness is reduced, making it unable to slow down or stop the crack growth. This results in brittle cleavage fracture, where the crack travels along specific planes in the material with little to no plastic deformation. The combination of low temperature and flaws creates a dangerous situation. First, low temperatures reduce the material's ductility and fracture toughness. This makes it easier for cracks to start and grow. Second, flaws provide specific sites where stress can build up, lowering the overall stress needed to cause a fracture. Additionally, the microstructure of the material, such as its grain size, plays a role. Larger grains can increase brittleness and raise the NDT temperature. Thermal stresses can also develop due to temperature differences within the material, promoting crack initiation at flaws. In practical terms, engineers must ensure that materials operate above the NDT temperature to avoid brittle fractures, especially in critical structures like pressure vessels and ship hulls. Heat treatments can refine grain size and reduce impurities, which helps lower the NDT temperature and improve resistance to brittle fractures. Regular inspections and quality control during manufacturing are also essential to prevent sudden mechanical failures. In summary, temperature and flaws significantly influence whether a material fails in a brittle manner. Understanding these factors helps explain why mechanical breakdowns can occur unexpectedly in products and structures under certain conditions.